Okay, hi. Thank you very much, and welcome everybody to today's event. Today we're going to be talking and we're going to be discussing how to write procedures with the human in mind, and the reason why we want to do that is because we want to avoid human error. So when we talk about writing procedures to reduce human error, what we really talking about is trying to understand behavior so we can understand actually the audience that's going to be using it. So a little bit before I begin, and I'm just going to give a little bit of background besides the bio that we have here, and it's because I think it's very important to be able to understand the how natural or how organic all of this is. And let me explain. I worked with the industry for many years. I was leading training or technical training or knowledge transfer departments. It doesn't matter what name we give. But I was leading basically the education program, different pharmaceutical facilities, manufacturing facilities, and I work with many different type of technologies from solid dosage to lyophilized to combination product and syringe filling. So I know about everything in terms of how different scenarios are in the manufacturing floor. So what I wanted to say is I was on the other side. It was not something that was just something that was created out of the blue, but it was something that I needed to implement when I was leading training because I was kind of, a little bit, I want to say, I want to be politically correct, but I was a little tired of the retraining all the time. And that's when we started looking for different answers. This is one of the vehicles that we use in order to increase human reliability, because at the end of the day, the human is your main asset. And I know we always say that, but in this case, I'm saying in a way of really meaning it. We have to provide all the tools. We have to provide with all the as much information and as much as we can to make sure that our main equipment, the most important equipment that we have in our manufacturing floor, which is the human, and a lot of people could debate that, but it is the most important equipment that we have on the floor, that we provide everything that it needs. So what I'm trying to say is we've been through the experience of trial and error, and what I'm going to talk about here is one of those things that was born with all the realities and all the real environments that we have in a manufacturing facility, and not just another out of the book. And I absolutely support the books. I have a PhD. I understand that also, but there is a reality. There is a gap. There is a missing link between academia and let's get this done, and that's the missing link that we're talking about here. Okay, so in order to start and understand how to achieve a procedure that is going to help you and help your organization and your workers to be successful, in order to do that, we have to understand the human. We have to understand the human error phenomena, because now understanding those weaknesses or advantages or things that we probably didn't know, or at least didn't know that we knew them, now we can say, you know what, when I'm writing my procedure, I know what I'm talking about. Imagine writing a manual to execute and to manage an equipment without understanding the equipment. So that's and how is it that it's going to be how is it going to be executing, if I don't understand the equipment? So let's talk a little bit about human error before we can start about talking about the rules of writing procedures. And when I say the rules, it's the rules for achieving human reliability. So we are going to start in the process, and today we're going to start with talking a little bit about understanding our equipment, our human equipment, and you will see that I use the equipment and the human words interchangeably. Why? Because it's an equipment. It is an equipment. It has capabilities. It needs to be qualified. It needs to be part of the validation process. It needs to be, it does need a shutdown, and it needs preventive maintenance. And it's basically the same thing. I actually sometimes start with this sentence. I have a dream, and I have a dream. And the dream is that one day we treat people like we treat our equipment, because we are very nice to our equipment. We are very careful with our user requirements, and we do IQ, OQ, PQ, GQ, whatever Q, and we make a job description because HR requires it for the requisition. So we really think about, we need this skill. Why? And those are the kinds of things that sometimes we miss when we're talking about humans. We are a lot nicer to the equipment. Or are you tired? Let's stop. The equipment is tired. But you stay another, shift because we don't have the equipment. It's tired. We need to double it to help and compensate for that. So let's start here. Let's talk about the facts. And this is information that comes from this document, which is called the Guidelines for Investigating Chemical and Process Incidents. And this is a division of the Center for Chemical Process Safety, which is another child of the American Institute for Chemical Engineers. And this is what they say. You know what? Yes, we have accidents. This happened. It's a type of industry that is by nature dangerous, right? So they say yes, 99% of accidental losses, except for natural disasters, which we are seeing, and it's another thing that I'm starting to think that we need to give a little bit of more emphasis, and I'm going to start studying a little bit about it, because we are having situations with weather issues that are affecting communities just because we didn't take some, barriers of defense and so on. And I say this, I'm from Puerto Rico, and you know what's happening now here. So yes, and there were other things that not natural disaster, but what we do to avoid it. But let's go back. It's just that it was too close to home for me not to say it. But yes, 99% of these losses begin with a human error at some point, because if you continue to go back and watch why, we might get to the point of creation. At some point it was a human that made a mistake, and so yes, that's true. But root causes of these accidents rely on management weaknesses, and that's very, very powerful, because that provides us with the opportunity to take back control, and that's the backbone of what we are going to be discussing here, in terms of the systems, in terms of the way we manage our different controls, and all of those are systems, and we're going to focus on them. And one of them is documentation, configuration, and control, which is one of our systems, and it basically covers the generation and the development of procedures. Okay, so that being said, we want to make sure that we have a system that takes care of it, or takes care of human error. So now that we know that systems can really be helpful, let's see what human error is. So what is human error? A lot of people will tell me, yes, there is one definition. Human error is human error, a mistake. Somebody did something wrong. That's okay. I understand that. But for the sake of science and application, because at the end of the day, all of these be a little bit entertaining, it's not entertainment. So what I'm trying to say, in our industry, I think we do have two types of, I know we have two types of definitions. The first one is that I did something. Right? It's an execution. There was an action in which I had a different result of what I expected to have. I wanted to have a beautiful cake, and I ended up with a, disastrous piece of whatever. I don't even know. So then something must have happened, and if I eliminate all other variables, the equipment was working, everything was, then you must have done something wrong. What was it? Well, probably I didn't know how to mix the ingredients, and this is what happened. Well, then that it's an error that created a defect. Okay, but there is another deviation, or I'm sorry, definition, which is any action or lack of a required action, so yes, there's an execution or lack of execution, that exceeds the system tolerance, meaning that it's breaking the rule that we established. And that means that if you deviate or that tolerance in the system is, and it's of course documented. Now I have to investigate whether I had a defect or not. My experience is that most of the times what we see is, yes, the person deviated from the procedure. Yes, the procedure said this, and this was not performed correctly, or the procedure did not have that instruction, or the procedure required and this sequence, and it was not executed in that way. So in this case, yes, these are things that happen, but still don't have an impact in the product, which is exactly what we want. We want to detect them before they actually become an issue, right? And an actual defect or a confirmed OOS, or no, we want to make sure that if we have them, that we can control the magnitude of the consequences and still recover from them. Of course, sometimes, but those are the ones that we can that we want to control. So what I'm trying to say is that the first definition basically says the batch is ruined, the product is, we can't do anything or a rework or something like that. On the other hand, the other one says, yeah, well, there was something that happened that exceeded the tolerance, but that doesn't mean that we have a major loss or anything like that. Most of the times is that I need to mix for 10 minutes and my procedure says, now you're going to mix, and in the batch record, well, it says it's going to be 10 minutes, and I did it for 15 minutes, but then, that's okay. Nothing happens. We investigate it. We can move on. It's a deviation. We are going to do a corrective action and then include in the procedure, that is 10 minutes again, and then let's train people that it says 10 minutes and now 10 minutes again, and I'm telling you. So that's how we work with this one. Okay? So what I'm trying to say, most of the time, and this is the first thing that I would do first before anything else, make sure that most of your evaluate what is the major contributor, and if most of your contributors for your deviations are things that are basically deviations that don't really have an impact, probably we are asking a little bit more than people can do. And I'll come back to this at some point, because it comes back to validation. It comes back to the fact that when we do validation, we do it in the best case scenario, we do it with the best operator, the best mechanic, the best engineers, and everybody is around, silence, validation in progress, and the area is isolated, and everybody's like really hoping for a certain time, Mr. Sharm, and yes, let's move on. Take out the ribbons, and now you manufacturing. Here it is. Deal with all the distractions, with all the possibilities of the things that are, of course, not considered in ideal circumstances. So, of course, you're going to get things. And that's why I say always, let's go back, because sometimes if you have 20 deviations that say that, we exceeded the time for 3 minutes, but nothing happened, I think we have enough information to expand that and then, proceduralize a quote-unquote deviation. I just wanted to bring this up because this is like sometimes the most effective way of getting rid of the major type of deviations, because the procedures are written for ideal circumstances. All right, so how do we control human error? Well, 80% of the success of any human error reduction program relies on making sure that human factors have been incorporated in our systems. And what is our systems, and what are those factors? Well, any aspect of the workplace or job implementation that makes it more likely for the worker to make a mistake. So what we want to make sure at the beginning is that, or what we're trying to say here is 80% doesn't really have to do with the people. Nope, it doesn't have to do with people. It has to do with the way we have designed, the way we have put together the process, the way we have written our procedures. So because remember, we don't really understand the human equipment. We are very good explaining equipment behavior, process behavior, product behavior. We know, we can hear about, stand close to an equipment and hear it and say, I know what's happening there. That little sound that doesn't sound that right. Sounds like a little star that was placed with the wrong grease, or we know that we can explain that behavior, but we don't really have experts to explain human behavior. We have industrial engineers, chemical engineers, process engineers, but we don't have human engineers. And again, I started talking about the most important equipment, the most complex equipment, and the only one that came without a manual. So of course, we need to understand a little bit about it. So 80% is not even considering the person that is there. It's considering human factors. That doesn't mean that it's anybody in particular. Human factors are universal. Okay. Then we have 20% that, yes, now we need to talk to you guys, because you know what? You've been trying to get away with things, or maybe you are, I can see all of you, I don't see anybody with procedures in their hands. What's happening? That will be more in the culture type of situation, or more into habits and individual behavior, and this needs to be addressed as well. But it's 20% of the success, because 80% will take care, of course. Human factors takes care of most of your issues, because the person doesn't even have a choice. It's like trying to force people to do things right in a good way. I'm saying force, but it's not like, everything is very sensitive lately. So let me just it's not forcing. It's inspiring people to do things in the right way. All right. So that being said, we want to focus on factors. Yes, we'll talk about humans in their individual way of managing procedures and all of that, but we are going to focus on the habits. Okay. Why we say this? Because you know what? Before we used to say that it was the person. It was always like, you're fired, you're retrained, and all of that. That's the old vision. That's the organizations need to start moving. And actually, I have to change that, because I said that, like, organizations need to start moving towards the new vision like 15 years ago. So let me update this one. You're old. That's it. Those are the organizations that are like in the third world. Our vision is that human error is the cause of accidents or incidents, and that you must find employees inaccurate assessment, wrong decisions, bad judgment. So at this point, it's you. It's we're hanging you. But the new vision, which is all based in studies and all the things that we have learned in the modern world, says that human error is a symptom of trouble deeper inside a system. That instead of trying to find out what you did wrong, your inaccurate assessment, because in hindsight, everybody is a genius, right? Instead, try to find out how employees' assessments and actions made sense at the time, given the circumstances that surrounded them. Okay, bye. I don't have anybody here. Tony, I know you're calculating yield. Can you just please, stop for a second. I just want you to check this by. right here because I don't have anybody else. Oh, okay, I'll do that. And then it takes from 20 to 30 minutes to get back to that level of concentration, which we call the zone, every time you get interrupted. So what we're trying to say is that we need to start using the information that is already part of the science of human reliability, human engineering, which is what we're talking about, and understand that yes, there are already know that people make mistakes because there is a reason for it, unless they want to make a mistake, which would mean that you wake up in the morning saying, yay, today I'm not going to follow the procedure, today I'm going to get in trouble, I just want to mess everything up, and then that's my goal. You know, that's very unlikely. Of course, unless there is really an intention of doing harm, but believe me, and that's not error, that's sabotage, and we'll talk about that. So we need to try to understand what happened, what was the situation and all of that, and procedures need to consider all of these things and be developed considering that they need to control anything that could potentially result in a human error. Okay? Now, what are the types of errors we can avoid with procedures? Most of them, if not all of them, and let me explain. We use in our methodology, we use different things. We use, you know, from designing of the, you know, what we call the human factors engineering. We work with communication. We work with teamwork. We work with training, supervision, management system, everything. But when we're talking about procedures are one of those factors that could be the best in controlling human error. And that's maybe the reason why they have had so much protagonism. The problem is that people think that it's just the existence of a procedure, that as long as I have a procedure, that's going to work. Well, no. It's a procedure that's written for that, right? So what types of errors am I trying to avoid? Well, there are 4 types of error, which are a combination of factors and psychological factors, okay? So we have, and psychologically, I could want to do something, so it would be intentional, okay? I want to do something. Or unintentional, which is something that happened to me. Omission would be something that I did not do, and commission would be something that I did. So it would be like commission is an action, and omission is a lack of action. Intentional and unintentional, what it means, and you must be saying, this woman just said that sabotage, you know, it's not an error. Well, intentional errors are not intended to do harm. So when we talk about intentional errors, it's like, you know what, I'm going to try and put a little bit, I've noticed this is not really working because remember, we have history, we have experience, we have tribal knowledge, we've seen it before. So at some point, you want me, all I can see in the cafeteria and every hallway is do more with less. We want to do it faster, but safer, and all of that is very good. I strongly support everything that has to do with process improvement, process excellence, Six Sigma, you know, everything. I actually my doctoral dissertation incorporates OEE in the basically about OEE and humans. So I do support it, but we have to be very careful that it's not really sending a message that what I want you to do and what's going to make this company successful and happy is that you do more with less steps, or that you reduce cycle time. So, and yes, we want to do it, but people get creative, especially this new generation. Be careful. They might make an app for that. So, for example, I'm going to say, well, this needs to be done in 5 minutes at 85 degrees. What if I put 87? Maybe it's done in 3. and boom, there you get. So that's why it's called intentional. It's playing with the system, trying to be happy and make you happy and make everybody happy. So there is no ill intention here. So I decide to say, you know what, I don't understand. Why do we have to add this ingredient and then sign? And then go back and add and then come back and sign. Wouldn't it make more sense to just add everything and then I sit and document, because that's the reason why we make mistakes. When in reality, the intention of doing that is not that is, and of course we want it to be correct, but the most important element here is that you don't miss a step. So you basically, defeating its purpose. Why? Because people don't understand the reason, and people break the rules when rules don't make sense to them. So if you want people to self-regulate, and if you want people to follow the procedure, they need to know why I have to do it this way and what will happen if I don't. And that will allow me to self-regulate. I won't need a supervisor because I know what could go wrong. And unless I want to do some sabotage, which is, again, another story, and actually I wouldn't talk about it. Those ones, go to HR. I really don't deal with those. Why? Because we already know. And honestly, I've never, actually, I've seen maybe once or twice acts like that. And sometimes sad to say, but sometimes the organization deserved it. I'm really sorry to say it. But that's another story, because nothing justifies it. But when you try to explain, it doesn't justify it, but explain it. Anyway, so intentional errors is because I want to do it faster. I'm going to skip this step. I'm good enough to not have to use the checklist. So in this case, there is a decision, an actual decision. In this case, we need to know why it made sense. So we will address this with procedures in some areas, and we'll talk about it. Then we have unintentional errors, which basically are things that happen to us. I forgot, or I confused, the shampoo with the conditioner, or the grease with the other one, because they looked very similar, and it was stressful. I was doing so many things, and that's the reality of every day in the manufacturing floor. I don't think anybody's sitting and having some meditation before taking the samples or the grease, just to make sure that they're focused and mindful and all of that. No, we are running around. We're trying to get everything done, and on top of it, we have our TVs. With a yellow OE there, that it's really pushing me to do things as fast as possible. So in this case, we want to address by designing tools to prevent or minimize the impact. So some of them we can incorporate in our procedures, and some of them we wouldn't be able to. But what I'm trying to say is, it's like most of this could be, and let me give you an example. An intentional error of omission. If I want to make sure you don't skip this step, I need to make it very explicit in my procedure, saying, caution, if this step is not performed, this could happen. Then, now you say, do I have to do that with everything? No, you're going to do that with the ones that are going to create you a deviation if they don't. So, or critical enough that you want to address as a preventive way in the procedure. The same with intentional of commission. You have to, the set point, it's 85. Going after 85 could start an overheating type of reaction that could result in this type of contamination or burn or whatever. On the other hand, if I don't want you to forget to pick a sample, maybe I incorporate some type of checklist in a place where I know you won't be able to miss it. It could be even in my procedure, one step saying, collect the checklist and sign here. There are ways of doing it, or alarms, or Pokeyoki. There are other things that we can incorporate here. And also in confusion, we can incorporate pictures. Look, this one is different than this one, or use in other type of approaches, a layout and all of that. So what I'm trying to say is there is many things that we can do. The reason why I spend some time in the types of error is because once you know the type of error, now the solution starts to come up to you. Like, oh, the person skipped a step because they don't think that's, and I can understand why they think it's not necessary. Come here, let me explain why. But and it's training, but it's not retraining in the procedure. It's retraining on the science, on the reason, what could go wrong. And not only helps for this, it also helps for managing unexpected situations. So I will incorporate some of the science in training regardless. But otherwise, you can incorporate the reason why in the procedure. This has to be done in this sequence. And that's why we always are very emphasize the fact that you need to make a distinction between important things and critical things, because this is going to be implemented for critical things. Otherwise, we won't finish. So, all right. So now that we know this, we are going to start talking about the procedures. And I wanted to show you this very quickly because I wanted to illustrate that, again, human error is a symptom of trouble deeper inside a system, and that there's a lot more than meets the eye when we talk about human error. So human error is not a root cause. It's very clear in the regulation. GMP states very clearly that human error needs to be fully investigated. So it's basically saying you have to find the root cause of the error. And if you have to find the root cause of the error, human error is not a root cause. And you can check to 11.20 and you will hear and you will read it. And also Europe is even more specific when it says not only to find the root cause of the human error, but that you also need to justify it, and not only start doing human error investigation when you know, you have to start even if you start suspecting it, and that's part of the European regulation. So I don't have a copy here, but I'm pretty sure you read it if you work with, if you manufacture for the rest of the world or just United States. Both of them require them. Actually, all of them, at the end of the day, require it. So as you see, and this would be the model that we use, but human error is not a root cause. We start by evaluating, if it's a system problem or a human problem, and if it's a system problem, we identify which systems, and the system that applies to procedures is documentation and configuration controls. And then we have the human performance problem, which are the actual operation controls, which is not the system, but the procedures, and then individuals, and then we have some other tools. But I wanted to show you that it's just one of the vehicles that we use for human error reduction. So, as you see, one of the categories for human error root cause determination would be procedure. In our methodology, procedure is category number 4, which is under operation control. So this one is the only one that we are going to be discussing today, the first one over here, procedures. So in our methodology, like I showed before in the model, we have different areas. We have systems, we have operation controls, we have individual performance. This is the tool. I'm not going to discuss the tool because we're just going to focus on procedures. But when we do human error reduction programs or we implement human error investigation programs, this is the tool that we use mainly. Is the backbone of what we use in order to implement and to work with these programs. And My intention is not that you can see it because, of course, it's very small, but I do want to tell you a little bit about it. The original tool, this one that you see here is one that we adapted to our methodology, and that it's more into making sure that it complies what GMP regulators require, because the original tool, which is the one that we've used as, of course, the first one. The original tool was developed in the 1970s approximately by the Department of Energy of the United States, and what they did was that they put together all the reasons why things could go wrong. And there are different things here. We added a few things that apply more to our manufacturing process because it was originally developed for accidents in nuclear power generation plants. So what we did was that we studied it, we went through it, we created a whole new methodology based on what the GMPs require, and this is the result of it. As you see, there is many things. In this tool, we have all the root causes why people make mistakes, all of them, 100% of them, okay? Why I know this? Because I've been using it for 20 years, and they're all there. And but there is one section, which is the one that I circled, that talks about procedures, and we're going to focus on only that one today. And let's zoom. This will be the procedure type of the procedure section. Let me go back just a little bit, just to maybe see very quickly the structure, and because it's sometimes easier to understand and to follow. What we use this tool for is basically for investigation. So we start here with the Y number 1, which will be human error. Then we have the problem type, Y number 2. Then we have the category, which is the Y number 3. This will be, this one over here is procedures, this one over here. And then we have the Y number 4, which is the near root cause, and then Y number 5, which are the root causes. That's the structure. So what we do is that we start with a causal factor, which is human error, and then we ask ourselves, was it a human performance problem? You know, yes, it was. So now we start coding it. In this case, we code it, and all root causes associated to procedures will be 4, will be C4 most likely, or B4, but it's no, basically it's 4. So 4 would be my category for procedures. Now, what are my near root causes for procedures? I told you this tool explains why people make mistakes. So it's going to explain now why people make mistakes due to procedures. Well, one of the reasons could be that they just didn't use it. They were not following it. Procedures were nowhere to be seen, right? That will be near root cause A. So far we have almost a code, which will be C4A. Now, why is it that people won't use the procedure? Well, probably they can't even find them, not available or inconvenient to obtain. So if we want to make sure that people use the procedure, they need to be available, and they need to be easy to obtain. 30 clicks. It's not easy to obtain, and password, and here, and now we have to enter the site, and then the company, and now the division, and now, yes, I've been there. 30 clicks, forget it. I know how to do this. This rings, forget it. Okay. Procedure difficult to use. I don't know how to, where is it that I'm going to put it? Everything is wet. There is nothing here. I'm doing a wash. I'm even washing the ceiling. What am I supposed to? There you go. The use is not required, but should be. And I'm gonna call supervisors and managers on this one. You walk around, and our experience is 90% of the companies and manufacturing facilities that we've visited or worked with, they work from memory. Nobody enforces the use. And then it says, use is not required, but should be. But then in order to be required. You need to enforce it and not just wait till the day something happens and then say you were not following the procedure. You know what? Nobody follows the procedure, never, unless they have questions. So what I'm trying to say is make sure people use them. Walk around. Where's your procedure? Do you need a copy of it? Do you need a tablet? I'm telling you, one workstation for 15, that's just trying to impress, I don't know who. Okay, so if you're going electronic, make sure you have the means to go electronic and provide a tablet to everybody. And I suggest the big one because we like to see the full picture. So, no procedure for the task. What procedure? I don't have a procedure. So if this is the case, then you fix it. This is in the case of doing investigation. But if you're going to write procedures, the first thing that you need to do is make sure that you understand every activity that needs to be performed. So you have a procedure for everything that is required to be used, that it's easy to be used, and that it's available to obtain. And then you eliminate that probability there. And then that will continue with the process. Let's say misleading. The format is a mess because corporate decided this format because I don't know why. No, procedures are written for the people that are going to execute, not for auditors, like a client told me not long ago. We write, who do you write procedures for? The auditors. Well, then we have a problem. So more than one action per step is a paragraph. You lose your place. Divide them. You need one action per step. No check of space, inadequate checklist, the graphics don't make any sense, this is digital, we used to have analog, we revised the procedure, but since we need to, get it approved by 12 before the system says it's overdue, forget about the picture. Ambiguous, excessive references, and so on. Or incomplete, typos, wrong information, and this one, we have seen one that is very, very common, and it's starting to get more common every day because every time we get more creative personnel in our facilities. Remember, our baby boomers, retired already, and they took away their all that amazing information, and we failed to immortalize it by either creating procedures from the ones that really knew the process, the one that have really validated the process, the one that, and we let them go. And that's something I work with a few projects, and it's beautiful to get people that have, before they retire, go through the process and leave that legacy to the ones that are starting and saying, you know what, this is how it goes, and it's a beautiful project. So, but not all of us did it, and we're losing that talent. If you still have time, please do. Okay, so basically what we're saying is that there is a lot of things and things that we sometimes underestimate. For example, the format. But what do we know about the format? Well, if your content is blah, then we don't care about the format. But if you have a good content, a good format could really add another 50% in human reliability because it will be designed for a human to follow and not for the audit to move on. Another thing about it is think about your hierarchy. We have too many levels of documentation. We like to make it very complicated, and then we create a child of the child of the child of the child. So, keep it simple. Policies, we start with laws and all of that, which is way up there. But then we have policies. We have guidance documents. We have instructions and records. Keep it simple. What we're talking about is instructions. Now, instructions are SOPs, but then you get work instructions, job aids, standard works, the maps, and the other thing, and another beautiful system that somebody, and with all these instructions are instructions. And we've done dozens of focus group with operators and technicians, and they just tell me what do you want me to do? 1, 2, 3, 4, 5. But we create all these confusions, and I know why. Sometimes we do want to bypass, the approval of procedures. So now we create a form, and now we create another document that they don't have to go through all the process. And at the end of the day, if they're not married to something, then something is not good. So think about your hierarchy, because sometimes your hierarchy is basically the problem. Okay, so what's a procedure? Very quickly, because that what we have discussed so far should be enough for you to write a good procedure. Why? Because you do know how to write your I'm not going to tell you how to write an instruction and this is where you put a comma and this is, no, that's not what we're talking about. We're talking about how to write procedures to avoid mistakes. And this is where we start by understanding who are we writing for. Now, let's understand what is it that we are writing. We are writing instruction, and instructions are step-by-step description of 2 or more actions that have a particular objective that's intended within a manufacturing process or system. It's a set of instructions that usually is written by someone, but to be used by others, which is going to change now, by the way, to provide a guide for a simple or a complicated process, but by all means, every procedure pursues the same goal, which is consistency of results. Now, remember, our technicians and our, not all of them will be able to write procedures. So will have somebody writing for somebody else to use it. But here is where we need to make sure that there is an alignment and that I don't have Dr. Emerson writing a full doctoral over the top dissertation with plus minus 0.0759 P alpha. I don't know, because I don't know anything about it. To execute that, we get many of similar things. For example, set the temperature to 85 plus minus 0.39. Do the calculation, give me a range, and you're helping. Those are the kinds of things that we want to do. So it is intended for execution. Now, how to create and maintain a procedure? Well, sometimes when we do this course, and soon actually we'll be doing this course, a one-day course for the FDA, and it's very interesting because this is something that we continuously repeat every time. It's better to invest time and effort in the design process of our procedure than investing any efforts in the process of investigations. Why? Because you do have the time. Jeanette, the problem is that we don't really have time. We have to implement that because we have a commitment. Okay, you have a commitment to have a procedure. So that's what you're going to give them. Perfect. Then if that's what you're looking for, then do that. But if you have a commitment to have a procedure because your procedure proved to be ineffective in an execution, and that created a deviation that then was presented to the FDA, and the FDA say you have to fix it. No, your commitment is not to revise the procedure. Your commitment is to put in place a procedure that will miss it. You either take it and do it on time, or you miss it, right? So, or you just lie to yourself. So, yes, we need to invest time and effort in the design process. The problem is that most of the time when companies hear about we are going to revise our procedures, what they think is like everybody's going to be running without heads, with all the procedures and having all the procedures in the revision process, and now all of a sudden quality has like 200,000 documents to approve, which of course, who's going to read it is 2,000. And there you go. That's the reason why we need to make a distinction between important and critical. There's not that many procedures that are critical. Most of them are important, but critical, not that many. You can find in different areas, maybe 12, 13. We've seen like, oh no, we have all of these are critical, like 78. When we took them out and we did a criticality assessment, all of them are important and all of them could create a deviation. But this one will basically throw your bat away. So let's start with these. So facts. It doesn't matter about the format. It can be effective as long as it has the information it needs to have. And of course, content. It can look good without having information, good information, stop signs, and the little hand and all these colors. That could create another type of unintentional errors, because we make intentional errors due to cognitive overload. And if I have so many stimuli from my procedure, my cognition is going to be overloaded trying to, put all that information in and accommodate it and process it. So, the black and white 1, 2, 3 is what your brain really cares about. And yes, if you want to incorporate color, it's because the color it's either going to serve a purpose or needs to be highlighting something. So there are things. We don't really care that much about having color, but sometimes when you have too much of it, it's overwhelming. I'm pretty sure when you saw the charts, the root cause determination tool that I showed you with all the root causes, you were like, whoa, yeah, that's how it feels. So the effort required to make a procedure look great is minimal compared to the effort it takes to contain and maintain an effective procedure, 1, 2, 3, 4, 5, in bullets, and move on. In fact, maintaining an effective program takes more time that most people are willing to invest, but still get a lot of rewards back. Okay, so the steps that we use is basically the same step that we use in every type of writing procedure process, because again, we're writing procedures and there is no problem with understanding that. So we do have a plan where we get the information, investigate where we, and we'll go through all of them, investigate what else do we need, organize the data, create the draft, revise the draft, and challenge the draft, maintain, and then continue to do the process, because it is a little bit of dynamic. So I'm not going to go through all of these statements in each one of these slides, because it's intended for you to be a reference document, okay, from now on. It gives you ideas of what we expect or what we think that you should be looking when you're doing each one of these phases. For example, the planning guide is where you start your putting together, the process in which you will have the main information to start writing the procedure. If you're revising a procedure, that helps as well. What you need to do is evaluate if there is a process without a written procedure. You're just, basically you're looking around and understanding the need. If the process has a written procedure, so try to know if it's incorrect or if it's not followed, if there is some issues with it. How many tasks, if it requires to be executed in a certain order. It's very important that we know this, because we are only going to use numbers for order-related execution. We want to be able to condition the brain that whenever they see numbers, it's because it's that order, period. It's not optional. We use bullets instead of commas for other types of listings, but when we are doing numbers, it's purely because it's sequential. Will the procedure be used by multiple users, areas? What are the expected results? It's very important to know that it's not to do the line clearance. It's to make sure it's cleared. I did the clearance. I went through it. I took everything out. Is it clear? I don't know. I cleared it. I don't. That's what we want to do. Oh, we need to send the fax or we need to send this information to Mr. Niemerson. What happened? Yeah, I sent the fax. Did you get it? I don't know. I sent it. We need to understand what is it that we need to achieve. We do, and we don't achieve because we don't even know where we're going. So it's important that we understand what we are trying to achieve. I'm not doing this because fun. I'm doing this because I'm going through the line clearance because I have to make sure that there's nothing there. And that needs to be part of the procedure. In the end of your procedure is the closure of the activity. So most of the times what we recommend is at the end of the procedure to say, this will be the standard that the work has been done correctly. Why? Because I can say, I don't know if let me go back. And this can trigger a let me check, because I'm saying that this was achieved. All right, so investigate, you get that working plan, you get familiarized with other process, equipment, materials, everything else. You want to talk to users, customers, collect information. We do focus groups that are very informal, and we just get together in a room, tell me about it. It doesn't have to be that, just get the impression, the feedback from the people that write, that design, that everything, and especially the ones that are going to follow it. I say this because we've tried. This is funny. We've tried to have technicians and operators come with us and write procedures with us. We negotiated and we agreed that they're going to help us. We're going to call us, but they hate writing procedures, and they hate to be in a room for weeks. So they try to escape every time they can to the floor. So what we have done is, you know what? Okay, so you come here at least once a day, and let's go through this, and then we go to the floor, and that they can do. But most of them, they don't want to be there. That's why we gave up on that idea. But you do want to interview everybody, and they'll tell you, and maybe you'll find one that wants to, right? And that will be good. Get all the blueprints, go back to basics. Sometimes when procedures are very complex, it's because we have over specified them with kappa and add this another thing, and add this another thing, and add and or eliminate this other thing. Another thing that usually I don't put, and I should incorporate here, is that if you put in your procedure, I worked in three companies. Well, two that I was an employee and holding a management position, in which I went to very intense consent decrees. And one of them, which was very, very harsh, and again, public information, was the Schering-Plough consent decree, I don't know, 10 years ago, something like that. Anyway, I remember in that time we had regulatory commitments that we needed to incorporate in our procedures, and we decided that we were going to identify them with a RC type of code to make sure that if we're going to, at some point, review, revise, or do some changes, that we know that that was a commitment, because that was a control that was being requested. So if you're going to remove it, make sure that you are covering it in some other way. And that's something that that really helps, and I think it was a great practice, because then somebody forgets about it and say, why are we doing this, and doesn't have the full story, and then it comes the follow-up visit, and the instruction was deleted. So locate everything and try to see if you can make one from scratch. Sometimes it's even better and easier, and with a better outcome. Then you're going to continue evaluate, and this is what I talked a little bit about this, but this is basically an example of what you can do to determine how many procedures do you need, or if you need one long procedure. A lot of people say, well, this procedure is too long. Well, then break it into pieces. Oh, but then we have too many procedures. Well, then staple them together. You need what you need. Forget about those numbers. You need what you need. I've seen people that, KPIs. Oh, we have to reduce the number of pages, and then all of a sudden everything is font type 10, and nobody can see it. Yeah, you have five less pages. We work around, but we'll get that green thing. I've been there. That's the difference. You can't lie to me. So what I'm trying to say is that you're going to have, for example, the first thing that we do is basically like a DACOM or something like that. The first thing we do, we prepare the area. Do you think that requires a whole procedure? Well, we prepare drums, we prepare this. Actually, no. That could be a step. Okay, so that would be steps over here. Now, then what you do? Oh, now we do the cleaning. Do you really think that could be part of the procedure? No, that needs another procedure, because sometimes we do major, minor, whatever. So that means that in the step you say, now you're going to do clearing, so now refer to the other procedure, and be careful with those references. This is just to get a story and see where is it, if I need a procedure, or if that's a step, or if that's an action, and it'll allow you to create the map of what it's going to, how it's going to look. And sometimes the operators come back and say, but you know what? This one over here requires a whole procedure by itself. So forget it. Then we move it over here to another procedure. I'm just giving you, don't mind my scratches and all this disaster here, but you know what? That's how we work. You should have seen the pictures. We break procedures, and we take the biggest room, and then we take all the pages and try to make a map of it. And when we then look at it, it's like, no wonder, no wonder this all happens. All right. So then that in here, now you already have an idea. You have an organization of your material. Now you're gonna start the draft, and you wanna coordinate with some people that you might need, SMEs, operator engineers, collect the templates and all the papers that need to be filled, and all the approvals, and say, you know what, I'm gonna initiate the draft. Now in the draft, very quickly, I'm going to go through the process of us reading, because this will make a difference in the way we write. When we read, we take some time, and the reason why it takes some time is because this needs to happen. I need to be able to recognize characters. So if it's a character in Mandarin or in another, it's not based like in American alphabet, then I won't be able to recognize it, so I stop here. But if I do, then I will continue and see if I can understand words. Now I'm using the same alphabet, but I don't understand anything in, I don't know, I'm trying to, because I do understand Spanish and English, but let's say, I don't know, French. Well, then I don't, so forget it. I'm not going to continue. But then we won't, once we do, if I understand the characters, the words, now I understand the concept, because I understand also the grammar that will provide structure to what I'm reading, and then I will be able to read. Now, if my words, my characters, and are too like advanced for, and I'm not saying, I mean, if I read a procedure and it says activate, activate, now I'm going to look for what I'm trying to say is we're going to use 5th grade English, and it's not about thinking less of people or anything. It's just that it's easier, turn on, turn off. And that's what we want to do, because we want to have words that are easily recognizable, because it's taking time of it's taking space for my cognition, and I won't be able to comprehend. If I have a big word, then I'm going to have a big chunk of my comprehension that is going to be compromised. And if I have these characters, plus, minus, and p, and average, and no, give it to me quickly so you can, and easy so it doesn't take a lot of time, because I only have so much. If it's difficult to read, I'm going to stop momentarily until I decide the meaning, so I'll continue to read, and at this point, resources are overloaded. I'm going to take them from somewhere, and at the end of the day, I lost train of thought. And that's why we need to understand the capabilities. And if on top of that, you add that this is a task that has been designed in ideal circumstances, and considering that I have all the time in the world, then it's going to take some other time. And then if it's stressful, probably I'll end up with this little bit of comprehension. But then it's my fault. So, that being said, we can get overloaded resources, and maybe we will just fail at the motivation of trying to not even read them, but follow them. So, all right, so now let's take, again, this is more, again, like a guide. Okay, but what we want to do is make sure that we are outlining main steps, and then we have sub-steps. Very quickly, that outline format is variable, which means 1, then 1.1, then 1.1.1.2, 1.1.1.3. Come on, they're disappearing. We haven't seen them in a long time, so they're pretty soon it's going to be part of history. And I'm not saying they're not good formats, but not for that type of execution. If you're going to write a procedure, probably you can do an outline, but that's not the procedure. If you're going to write a story, probably you want an outline, but that's not the story. So it could be part of it, but it's not the procedure. So it's not intended for that. So what you want to identify is the main steps, just like in the storyline, and then sub-steps that will be part of that step, or if you later determine that you need a sub-step, it could also happen. I wouldn't go farther than that. More than 3, it's or 2 or 3, it's way too much. Okay, so we're gonna write steps as commands because it's not optional. Turn, open, 1 implied action per instruction, and when the sequence is important, we will not only use the numbers, but sometimes we will need to put a caution there to make sure that we are not ignoring that requirement. We need to incorporate the how, what, where. It's important that if you're going to, turn off the main switch located at the mezzanine or something like, if it's something that is statically there, not like take the foil from the second shelf in the laboratory. No, not that. But there are certain things that you have to let them know where is it, and so to make sure you incorporate how I'm going to do it, what I'm going to do, where I'm going to do it, and then I want to also know if I did it right or wrong, right? So at the end of the procedure, you could write your job will be completed and well done if the autoclave is 100% unloaded and the cards have been moved to the 5S in area, indicated area or whatever. And then that's, okay, this is it, oops, okay, I'm done, check, motivated to go and do something else and get it done. Then the why. Why must I do it? Why should I do it in this order? And why I can't do it in a different way? And this is what we address with warnings and cautions. We use warnings for safety-related risks and caution for quality-related risks all the time. So if people see warning, they know that there is a safety risk. If people see caution, oops, something can generate a defect here. So sometimes we do have to identify these steps and why I have to do them the way I have to do them. Which ones? The critical ones. Remember, we are just doing this for the critical ones. When I say critical, I'm going to give you an example very quickly. I have two critical parameters. They are both critical. One of them I can get through my historian. The other one is non-recoverable. All of a sudden, the non-recoverable is critical. The other one is the important. So let's understand this type of definition, because that's what we're looking for. We only have certain capabilities. Humans have certain capabilities, so we need to eliminate the burden as much as possible and let them know if at some point you only have little pieces of cognition available because of everything that is happening, this is the one that you're going to document. So make it visible. We use what we call attention-grabbing features, which could be a double border or a color or something that says this one right here makes or breaks. Help me make a decision. When we're all over the place, we make very bad decisions because, again, considering the circumstances that surround us. If we go back to the first slide. All right. Then all this material will continue to give you some rules. I'm going to give you an example. We need blank space on the left side of our of the paper because we read from left to right, so our cognition needs to be blank for a second and then start getting information. That's why we don't care that much about the right on the margin. So left 1.5 to 2. 12 and in terms of the font size, that we need to see it sometimes from distance, so make sure it's big enough. And we recommend Arial or Times New Roman because they're mostly because they are true to their size. Some fonts are, say, 12 and they're very small, but these are very, these have been proven to be very good to read. And actually recently, because before we were a lot better reading Times New Roman than Arial. Why? Because he has serif, and in Arial is a sans serif type of font. The serif is the little curve that makes it a little bit more formed. That's serif, which is with serif. And then Arial doesn't have that. It's very square. Then it's sans serif, sin serif, without serif. And you learn another. I'm just giving you a very useless information, but it's interesting. We're going to use mixed case. It's used for words or steps. Because we are going to use all caps when we are going to try to emphasize something such as if, and, auto, warning, no, not. Okay, those are the times that we are going to use warning, caution. Okay, warnings and cautions, we're going to try to incorporate them, you know, when we understand that they are going to be valuable. We want to be very careful not to overdo it, just like we do with many things that eventually, you know, people lose respect because they're not attention grabbing anymore. So we say no more than 2 per page. Actually, you can have more, but just make sure that you're not overdoing it and just canceling one with the other. The title should be the largest item of the page. Everybody knows where they work, so the logo doesn't have to be that big, okay? So the title. And then the control features should be small because we are not supposed to be controlling documents on the floor. That happens at the control and documentation and configuration control groups that will do that. But what we want to make sure is that we try to avoid extra numbers. We use 1 and 2, that the title is the largest in the page, that sections are a little bigger, like 14 points, and then the rest of the body would be miscased, 12, either Arial or Times New Roman. We are not going to number sections, even though most of the systems that we have in the industry do. So if that's the case, well, we can't do anything about it. It's not such a big a deal, but we are trying to condition the brain to see numbers in assigned order. But again, sections, sometimes we can't do anything about it. But if you can, don't use numbers there, right? And in the last instruction step, and you can incorporate the result there. Make sure that the paper screen color is appropriate, as seen blue over blue in the screen. Always white and black is the standard. But if you're going to use numbers, just make sure you use the color coding rules, which I don't have here, I think, but it's very easy to find, and they'll give you the attention grabbing level and the contrast, how to reach better contrast, especially for screens. Make a decision whether you're going to use electronic or hard copy. They both have advantages and disadvantages, and we'll discuss in a minute. Make sure you have a very good format. If you're going to use outline, then it's because it fits that. If you're going to use T-bar, it's because it fits for that. Just make sure that that it makes sense. We recommend T-bar, and we're going to see it in a second. Place features are added if the task must be coordinated between two or more users. So if there is a particular activity that needs to happen while I'm doing this, but as an operator, but the mechanic needs to do something as well, it needs to be there, that place script. Now the mechanic performs this. And follow the formats and rules. You should have an attachment with the rules. Everything that we have discussed, you should have the presentation and the examples of the formats that will be part of it. So that the advantages and disadvantages for electronic, well, yes, it's just think about the user. What's the advantage for the user? The advantages is that it's consistent distribution throughout the facility. Is that an advantage for the user? Control of documents. Is that an advantage for the user? Users can access the most current procedure at a time. Is that an advantage for it? If you say yes, then go ahead. Disadvantages. Electronic information networks requires a special format to provide. If it's an advantage, what I'm trying to say is, don't forget that you work for manufacturing, and manufacturing doesn't work for you. And I say this with a lot of respect. I worked in training, so I worked for manufacturing. The operator was not going to go to my office to do anything. If they needed something, I would go there. If I had a specialist that was assigned to the laboratory, the desk of that specialist is in the laboratory. Of course, it reports to me, otherwise we'll be doing testing. But what I'm trying to say is make sure that support systems work for manufacturing, because that's what we sell, and manufacturing only is responsible for conversion, which is to take this material and make it and create this final product. Everything in the middle, of course, is part of what we are going to support, and we're going to make sure that it has the quality, but be careful that we are not asking manufacturing to work for us and that we work for them. And that's why once we understand that, believe me, your procedures are going to be very good. And if we understand and use these rules of how to write and how to present the data and how to grab the attention for critical steps and so on, we will have a very good product, okay? So we recommend a very simple format, which is the T-bar, which is two sides, the what, the how, and then when something is dangerous, the why, okay? Remove the and then in the details. So, and this is the important thing about this. The what is what this is the section that the experienced and seasoned worker will follow, because sometimes they reject procedures because they see it as an affront to their skill, okay? So sometimes they don't want to use it. But in this case, what I'm giving you is the left side of the procedure, which is this, and that. And of course, a conditional statements, which is something that they will need if at some point, if this happens, then do this and that. And then the how, for less experience, is a little bit more of an optional reading, and then it will have the cautions could be here or here. It all depends how you put it. As long as the information is there, it will be easy to follow. So I'm going to give you an example of how a real thing looks like. The procedure with the steps on the left side, the details, the cautions, the warnings, and so on. So you can see how it finally ends up being a procedure. And we also incorporated a format for you in the, I think it's a Word template that you can use for this, okay? It's just an example, but this is how it will look like. It's a simple procedure, steps, verify this, if this is not this, then do that, then the other one, open the tray, then pull this other whatever, the rack, and close the tray. Now, if there is some caution, I'm gonna see it right there. So, it's one of the examples, okay? This is a bigger screenshot of how it looks like. Okay, so what I'm trying to say is that it's simple, it's clean, it has the white space. We need the white space for our brain to, to get ready for the rest. So if you see, it does have a lot of information, but the information is structured. We usually have texture, but not structure. And here we have divided them and put them in a different, presented in a different way, and these are different types of doing it. Okay, now once you're done, don't mess it up. So when you're doing your corrective actions, make sure you are not creating rules for exceptions. If you have a random situation, you have to address them separately and make sure that you address them because of their own merits, but something is happening if you're having too many random issues. So probably you want to take a look, not necessarily the procedure, probably some other stuff. What I'm trying to see is to get this type of random situations, maybe you want to address it separately. But in this case, it's different procedures, then you don't have a choice. You would have to address them separately. But if it's a systematic issue trying to change the system and not the procedures, for example, if everything, it's not everything, but most of our issues is that our procedures are incomplete because there is situations that have not been covered, then now you have to do kind of a project and address it as a system and then go back to the system and say, what is happening that our procedures, when they are being developed, end up being incomplete? There is something in the way we're creating procedures, and that takes you back to documentation and configuration control. And sometimes you just have one out of the blue, and this is the sporadic event. Be careful, we've seen many sporadic events. Like, how many sporadic? Oh, we have 54. Well, that's not sporadic, okay? Sporadic is something that you know that the likelihood of happening is very low. We are not going to do anything about it because sometimes doing something about it creates more problems because you are creating rules for exceptions. Unless it's so critical and in which then you would need to address it. And most of the times when these things happen, and they're very critical, most likely your next step is automation because you can only control so much. There is always going to be a 0.001 possibility of mistake. So in this case, most likely you will need to remove the human interaction. The human interaction. The human is going to be there. All right. Well, this is basically my presentation. I hope it helps. I know I took a little bit more time because I do want to have some time for questions. But again, the intention of this event is to understand the reasons. Once we know where we're going, the likelihood of getting there increases, and there is no one way of doing this. So that's why when we learn math, they will give us all of these hard time thinking and making sense out of calculations. So when we use the calculator, we do know what we're talking about, and that was this all about. So now I'm going to send it back to the moderator. This concludes my presentation, and I'm open for questions.